Hello everyone, welcome. In today's tutorial, I'm going to take you through probability distributions such as binomial, normal distribution, Poisson, and many more with questions and how to answer them. So without wasting much time, let's start. The first question says, for a Poisson distribution, if mean mu is equal to 1, then probability that x is exactly 1 is. In Poisson distribution, the probability of x is equal to mu exponent x times e exponent negative mu divided by x factorial. The mu represents the mean, and then the e is Euler's number. This formula can also be written as lambda exponent x e exponent negative lambda over x factorial. So to find the probability that x is exactly 1, it will be, since the mean is 1, we say 1 exponent x, which is 1, times e exponent negative 1 divided by 1 factorial. And 1 factorial gives us 1. Okay, so the answer will be e exponent negative 1. And e exponent negative 1 is the same as 1 over e. So the correct answer for question 1 is A. So let's proceed to question 2. A standard normal distribution is a normal distribution with. The correct answer for question 2 is B. A standard normal distribution is a normal distribution with mean of 0 and a standard deviation of 1. So the answer is B. Question 3 says, a multiple choice examination has 15 questions. Each question has 4 possible answers, of which only 1 is correct. The probability that by just guessing, a student will get exactly 7 correct is. Now we are going to use binomial to solve this question. And to do that, we need to know our n. N is 15 questions, number of questions, so 15. Now, the probability of getting 1 question correct is that in 1 question, there are 4 possible answers and only 1 of them is correct. So that will be 1 over 4. 1 is correct divided by the number of possible answers. So 1 over 4. And the binomial formula says that n combination x, then p exponent x times 1 minus p exponent n minus x. This 1 minus p can also be written as q. Okay, so the question wants us to find the probability that a student will get exactly 7 correct. Exactly 7. So that will be, our n is 15, isn't it? So 15 combination 7. Our p is 1 over 4, which is the same as 0.25. So times 0.25 exponent 7 times 1 minus p will give us 0.75. Since our p is 0.25, so exponent 15 minus 7. So when you put this on calculator, to get combination, you press shift and the division key. Combination will come. So you can press 15, shift, then division, the combination symbol will come. So when you put this on your calculator, you get 0.0393. So the correct answer for question 3 is A. Let's proceed to the next question. Question 4 says, if the z-score associated with a given raw score is equal to 0, this implies that the raw score is the same as the mean. So the correct answer is D. The reason is, the formula for z is x minus mu divided by standard deviation. Now, if let's say x is 200 minus, and the mean also is 200. Let's even say we don't know the standard deviation. 200 minus 200 is 0. 0 divided by anything is 0. So meaning we've gotten z-score to be 0. The only thing that can make you get a z-score of 0 is that when the x value, the raw score, is the same as the mean, you definitely get a z-score of 0. So that's why the answer is D. The raw score is the same as the mean. So let's proceed. Question 5 says, the time it takes for a dose of a certain drug to be effective as a sedative on lab animals is normally distributed with a mean of 1 hour and a standard deviation of 0.1 hour. If x represents this time, then probability of x greater than 1.1 is. So to do this, we need the z-score. So to find the z-score, we say z is equal to x minus mean divided by standard deviation. Now, what is our x? Now, you consider your x as this, 1.1. So we substitute it there, 1.1 minus, the mean is 1, and the standard deviation is 0.1. So 1.1 minus 1 is 0.1, isn't it? Divided by 0.1, you get positive 1.00. So in order to get your answer, we sketch a curve. It's not compulsory, okay, but it's good to sketch it so that you know exactly what you are doing. Now when you sketch this curve, you know in a standard normal curve, the middle is 0. So where can we, and these sides are negatives and these are positive, okay. So where do we plot 1? Let's say it's somewhere here. So 1. Now this probability of s greater than 1.1 can be rewritten as probability of z. Since we've converted it to z, you can now write it as probability of z greater than 1 because we got z score to be 1. So now this right side is area more than, and this left side is what? Area less than. So the question says greater than, so it means we should find this area. So to get this area, first we need to go to the z table. Now, to check the z table, whenever you are checking a positive z-score on a positive z table, the answer you get means area to the left. When you also check a negative z-score on a negative z table also, the answer you still get also means to the left. But if you do otherwise, as in, if you check a positive z-score on a negative z table, the answer you will get will mean the right. Now, let's check 1.0 on the z table. Now, take a look at this z table. This is the positive and this is the negative. Now, when you check the positive, this side, it starts with 0.500. When you check the negative one also, it starts with 0.500 at this side. Okay. Now, these two z tables are full z tables. We have the half one also. For the half one, it starts with 0.000 here to 0.000. Be very careful when you want to check a z table. You don't just check and write anything. Know the type of z table you are checking and how to read it. So I'm using a full z table. I'm not using a half one. In case your z table is the same as mine, no problem. But if it is not the same, please get the one that starts with 0.500. Okay. In another video, I'll show you how to read the one that starts with 0.00. You still get same answer at the end. So now, we want to check positive 1.00, isn't it? So to check it, this is 1.0, isn't it? 0. So the answer will be 0.8413. There's a point here. It means 0 comes before the point. So 0.8413. Now remember, I told you that when you check a positive z-score on a positive z table, the answer you get means area to the left. So when we checked, we got 0.8413, isn't it? Which means area to the left, 0.8413. But we need the area to the right, which is shaded. Now, since the total area under the curve is 1, and you know area to the left to be 0.8413, you can easily get this area as 1 minus 0.8413. So 1 minus 0.8413 should give you 0.1587. So the correct answer for question 5 is D. Another way of checking it is, if you go and check this positive z-score on a negative z table, like this, negative 1, you see that you get 0.1587 straight. That was why I said earlier that if you check a positive z-score on a negative z-table, the answer you get means area to the right. But if you check it on its own positive z-table, the answer means to the left. So you have to be very careful with reading the table. So the answer is 0.1587. So let's proceed to the next question. The lifetime of an electrical component is known to follow a normal distribution with mean, that is mu, equals 2000 hours and standard deviation equals 200 hours. Find the probability that a randomly selected component will last. Use this to answer question 6 to 8. So question 6 says, will last more than 2200 hours. So to find this, we need a z-score first. And z is equal to x minus mu divided by standard deviation. Now you consider this as your x. So 2200 minus, the mean is 2000 from the question. So 2000 divided by the standard deviation of 200. So 2002 minus 2000 divided by 200 will give you positive 1.00. So when you sketch a curve, it's not compulsory to sketch a curve, but it's good to do that so that you know exactly what you are doing. So 0 is here and 1 will be somewhere here, isn't it? And the question says more than 2200. It means more than 1. So area more than is this side, meaning the question wants us to find this side. So to get it, we need to go and check positive 1.00 on a positive z-table, isn't it? So let's check. 1.00 gives us 0.8413, which means area to the left, 0.8413. So to get this area we are looking for, it should be 1 minus 0.8413. And that will give us 0.1587. So the correct answer for question 6 is B. So let's look at question 7. Question 7 says, less than 2200. Now for this, 2200 is the same as this. So in exams, there's no need computing the z here. You know the z is 1. Okay. So we sketch the curve also. So 1 is somewhere here, isn't it? But this question says less than. So area less than is this side. So it means this question wants us to find this area. So if we check positive 1.00 on a positive z table, we get 0.8413, which means area to the left, isn't it? And the question also wants us to find area to the left. Less than is the area to the left. So the answer is 8413 straight. So the answer is C. Question 8 says, between 2000 and 2400. To get this, we are going to find two z's. The first z will be x, the first x, which is 2000. So 2000 minus the mean, which is 2000, divided by the standard deviation, which is 200. So 2000 minus 2000 divided by 200 will give us 0. Then we also find a second z. To get a second z, we take the second x, which is 2400, minus the mean, which is 2000, divided by 200. So 2004 minus 2000 is 400, isn't it? Divided by 200, we'll get positive 2.00. This is 0.00 or 0. So let's sketch the curve. Now we know that the middle of the curve is 0, isn't it? So we already got our 0, z1. Now remember, negative scores will be here and positive scores will be here. So we have positive 2. So let's put it somewhere here. Positive 2.00. But the question wants us to find area between 2000 and 2004. It means between 0 and 2. So it wants us to find this area. So to get this, we can check area to the left of 0 on the z table. But there's no need checking because we know that the total area under the curve is 1. When the curve is divided into 2, you get 0.5. So area to the left of 0 will be 0.5000 or 0.5. Now, let's find the area to the left of 2 also. Area to the left of 2.00. So we go and check this positive z-score on a positive z-table. So we have 2.00. It will give us 0.9772. So we have 0.9772. So to get the area between them, we say area to the left of 2, which is 0.9772, minus area to the left of 0, which is also 0.5. So that will give you 0.4772. So the correct answer for question 8 is D. So let's proceed to the next question. Question 9. A normal distribution has a skewness of. The answer is C. It has a skewness of 0. The reason is it's neither skewed to the right nor skewed to the left. Another reason also is, coefficient of skewness is equal to 3 into bracket mean minus median divided by standard deviation. Now, but in a normal distribution, the mean is equal to the median is equal to the mode. Let's say the mean is 45 and the median too is 45. 45 minus 45 is 0. 0 times 3 is 0, and 0 divided by standard deviation is 0. So you definitely get a 0. So the answer is C. So let's proceed to the next question. Question 10 says, a fair coin is tossed 5 times, and the number of heads recorded. Find the mean number of heads that will be recorded. So to do this, how many times was the coin tossed? The coin was tossed 5 times, so meaning n is 5. Now, you need to find the probability of getting a head in one tossing. So when you toss a coin just once, what is the probability of getting a head? It's 1/2. So to get the mean will be equal to n times p, which is 5 times 1/2. So 5 times 1/2 will give you 2.5. So the correct answer for question 10 is C, 2.50. So let's go to the next question. Use the information below to answer question 11 to 12. I think this is a mistake. It should be question 11 to 15. So 11 says, find the mean of the normal curve. Now look at this normal curve. The middle value is 15. So the line that divides the curve into 2 equal parts, the score over there is 15. So that is the mean. Okay, so the answer is C. Then question 12 says, find the standard deviation of the normal curve. To get the standard deviation, look at the score next to the 15 and look at the score here. If you trace their height, the height of this to this, they are the same, isn't it? So what's the difference between this and this? Is 2.5. That's 17.5 minus 15. 2.5. Here to 15 minus 12.5 is 2.5. So it means the standard deviation is 2.5. So the answer is B. So let's proceed to the next question. Question 13 says, if the random variable x follows a normal curve, find probability that x is less than 20. So we need to find a z-score. And to get a z-score, we need the mean and the standard deviation, isn't it? So let's go back. We've gotten our mean to be 15 and our standard deviation to be 2.5, isn't it? So we know mean 15, standard deviation 2.5. So to get a z-score here, it will be the x20 minus the mean divided by 2.5. So 20 minus 15 is 5, divided by 2.5, you get positive 2.00. So we sketch a curve for it. So 0 is always at the middle. So let's say 2 will be somewhere here. But the question says less than 20. It means now less than 2. So area less than is this side, meaning the question wants us to find this side. So to get it, first we need to go and check 2.00 on the z table. So let's check it on a positive z table. 2.00. We get 0.9772. 2.00. In case you are checking 2.01, it will be 2.01. So the answer will be this one. but you are checking 2.00, so 0.9772, which means to the left, isn't it? So 0.9772. But according to this question, we also want area to the left, so meaning we've gotten it straight. So the answer is D, 0.9772. Question 14 says, if the random variable x follows the normal curve, find the probability that x is greater than 12. So z will be equal to 12, which is our x, minus the mean, 15, divided by 2.5. So 12 minus 15 is what? Negative 3, isn't it? And negative 3 divided by 2.5 will give you negative 1.2. So if we sketch a curve, if 0 is here, negative 1.2, let's say it's somewhere here, negative 1.2. The question says greater than 12. It means greater than negative 1.2. So this area is greater and this area is less. So we need this area according to the question. So to get this area, first we can check negative 1.2 on its corresponding negative z table. So let's check negative 1.20. This is negative 1.20. That is 0.1151, isn't it? So which means that to the left. Okay, so 0.1151. 0.1151, which is the area to the left. But we want the area to the right, which is the shaded area. So to get the area to the right, we say 1 minus 0.1151. So 1 minus 0.1151 will give us 0.8849. So the correct answer for question 14 is B. Another way of checking it is, this negative 1.2, you can go and check it on a positive z table. But remember, the answer will be the right. It won't be the left anymore. Let's check negative 1.2 on a positive z table. So 1.2. We get 0.8849. So you see that we get the answer straight, 8849. So question 15. If the random variable x follows the normal curve, find the probability that x is between 10 and 20. So to do that, this is x1, this is x2. So meaning we are going to find two z's. So z1 will be equal to 10 minus the mean, which is 15, divided by standard deviation of 2.5. So 10 minus 15 is negative 5, divided by 2.5, we get negative 2. And we also find z2, it will be 20 minus 15, divided by 2.5, and it will give us positive 2.00. So it means that probability that z should be between negative 2 and positive 2. That's the meaning. So let's sketch a curve for this. So 0 is here. So let's say positive 2 is somewhere here. So negative 2 will be somewhere here. But we want to find the area between them. So between. So to do this, we check positive 2 on the z table. Positive 2.00. So 2.00, it will be 0.9772. So it means area to the left. 0.9772. When we also check negative 2 on its corresponding negative z table, we get 0.0228. We get 0.02, which also means area to the left, 0.0228. So to get the area between, we say 0.9772 minus 0.022. So that will give us the area between them, which is 0.9544. So the correct answer for this is C. Another way of checking it is, when you check this negative 2, and it gives you 0.0228. Since the positive z-score is the same as the negative z-score, 2, 2. Just that this side is negative, this side is positive. Then, this area 2 will be 0.0228. So if this area is 0.02, to get the area between, you can add this and this together. When you add them together, you subtract their addition from 1. You will get the same answer, 0.9544. You can try it and see. Do 0.0228 plus 0.0228. What you get, subtract it from 1. You get same result here. So let's proceed to the next question. Question 16 says, if the IQ scores are normally distributed with a mean of 100 and a standard deviation of 20, then the probability of a person having an IQ score of at least 130 is. So we need a z-score here too. So x, which is 130, minus the mean, which is 100, divided by the standard deviation, which is 20. So 130 minus 100 will give you 30, divided by 20. So that will give you 1.50. So after getting the 1.50, we can sketch a curve for it. The middle is what? 0. So let's say 1.50 is here. So if 1.50 is here, the question says at least. At least means x, which is the IQ, is greater than or equal to 130. That's the meaning of at least. So in terms of z, it will be z greater than or equal to 1.5. So which area is greater than? This area. So the question wants us to find this particular area. So to get it, we go to the z table to check for 1.50. So let's check 1.50. That is 0.9332. So which means area to the left. So 0.9332. So to get this area, we say 1 minus 0.9332. So 1 minus 0.9332 will give us 0.0668. So the correct answer for question 16 is D. Question 17 says, the area under any normal curve that is within 2 standard deviations of the mean is approximately, the correct answer is A. If the question says 1 standard deviation, then the answer will be 68%. If the question says 2 standard deviation, the answer is approximately 95%. If the question says 3 standard deviation, then the answer will be 99.7%. 99.7% is the same as 0.997. 95% is 0.950. So the answer is A, 2 standard deviations. Okay, so let's go to the next question. Because of economic conditions, a firm reports that 30% of its account receivable from other business firms are overdue. If an accountant takes a random sample of 5 accounts, determine the probability that, we should use this to answer 18 and 19. None of the accounts is overdue. It says 30%. So meaning that P, probability is 30%, which is 0.3. But the question says if an accountant takes a random sample of 5 accounts, so meaning N is 5. So to use the binomial formula, you are going to find a probability that none of the accounts is overdue, meaning X is equal to 0. None. None means 0. So that will be what? 5 combination 0 and combination X times P exponent X times 1 minus P, which is Q, exponent N minus X, 5 minus 0. So when you put this on your calculator, you are going to get, and 5 combination 0 is 1, times 0.3 exponent 0 is also 1. 1 minus 0.3 is 0.7. So 0.7 exponent 5 will give you 0.16807. So when you multiply it by 1, you still get a 0.16807. 0.807. So the correct answer for question 18 is B, 0.1681. If you bring this to 4 decimal places, it will be 0.1681, which is B. Question 19 says, exactly 2 accounts are overdue. So probability that X is exactly 2. That will be 5 combination 2 times 0.3 exponent 2 times 0.7. That is 1 minus 0.3 exponent 5 minus 2. So if you put this on your calculator too, you get 0.3087. So the correct answer for question 19 is A. Question 26. The best point estimate of the population mean is there. It is the sample mean, C. Question 21 says, find the 2z values so that 48% of the middle area is bounded by them. What this means is that if you have a curve and the middle is 0, the question says so that 48% of the middle, it means that somewhere here to here, equal length from 0. From 0 to this place, you have equal length as 0 to this place. So the whole of this part is 48% of the total area under the curve. So that is 0.4800, this area. So the question wants us to find the z-score that will be here and the z-score that will be here. The z-score that will be here will be the same as this place, but this will be positive and this will be negative. So to get it, when you divide this into 2, you know 0.48 divided by 2 gives you 0.2400. And this side will be 0.2400. I've divided here to here by 2. So this will be 24. Now, if this place is 24, we know that the entire area from here, from the middle here, going is 0.5. From the middle here going is 0.5, isn't it? To this side, 0.5. So if it is 0.5, then to get the entire area from here to here, it will be 0.5 plus 0.2400, which will give you 0.7400. So to find this z-score, since we've been checking positive z on the positive z table to get the area, it means that we can also check this to get the z-score back. So let's go to the z table. So when we come to the z table, we are going to check for 0.7400 at the middle here. So 0.7400. Now this is 7389, this is 7422. We can see 0.7400, but it means it will be between these two. So since it will be between them, we are going to take the z-score of this person, which is 0.64. 0.64. And we take the z-score of this person, which is also 0. Then we find its average. Will give us 0.645. Isn't it? So 0.645 is the answer. But here we can see 0.645. We can see 0.64. So you are still free to choose A as your answer, plus or minus. It means the z here will be positive 0.64 and this will be negative 0.64. That's the meaning. So let's proceed to the next question. Arrivals at a fuel filling station average 15 vehicles per hour. Suppose the attendant leaves the service booth for 5 minutes. Use this to answer question 22 and 23. 22 says, what is the probability that no vehicle arrives for service during the 5-minute period? Now, the question is based on 5-minute period. But when you look at the mean of 15 vehicles is for 1 hour. It's not for 5 minutes. So if you want to use the Poisson formula, the mean must change. So to solve this, since we know that 15 vehicles is for what? 1 hour. Then we need to find the number of vehicles for what? For 5 minutes. And 1 hour is the same as 60 minutes. Isn't it? So we don't know the number of vehicles that will be for maybe 5 minutes. So to get it, we can say 5 over 60 times 15. I'm doing cross multiplication. 5 times 15 over 60 to get x. Okay, so for this you get 1.25 as the mean for 5 minutes. So if you're able to get the mean for 5 minutes, which is 1.25, then you can say probability that no vehicle, that's x is equal to 0, is equal to the mean, which is 1.25 exponent 0 times e exponent negative mean divided by x factorial. So when you put this on your calculator, you get 0.2865. So the correct answer for question 22 is C. Question 23 says, what is the probability that at least one vehicle arrives? Now, probability of at least one means the probability that x is greater than or equal to 1. When we say greater than or equal to 1, it means probability that x is exactly 1, or probability that x is exactly 2, or up to plus probability that x is exactly n. But we don't know the last term. So since we don't know the last term, it means we can't use this process to solve it. So the best way to solve it is to use the complement method. And it says that probability that x is greater than or equal to 1 should be equal to 1 minus probability that x is less than 1. The opposite of greater than or equal to is less than. So, which will give us 1 minus probability of x less than 1 means probability of what? None. So in the previous question, we saw probability of none to be 0.2865. So we can say 1 minus 0.2865. So 1 minus 0.2865 will give us 0.7135. So the correct answer for question 23 is A. I think it's a typing mistake. It should be 7135. Okay, so the answer is A. So let's proceed to the next question. Question 24 says, 10 items are selected at random from a production line. Find the probability of exactly 9 non-defectives if it is known that the probability of a defective item is 0.05. So the number of items selected is what? Is 10. So n is equal to 10. And probability of non-defective should be 0.95. That is 1 minus defective. Okay, now to solve this, you see the question is based on non-defectives. That's why I'm finding the P for non-defectives. So the question says exactly 9. So probability that x is exactly 9 should be equal to n, which is 10 combination 9, times probability of exponent 9 times probability of defective exponent 10 minus 9. So if you put this on your calculator, you get 0.3151. So the correct answer for question 24 is C. So let's proceed to the next question. 25 to 26. A firm receives on average 3 calls per hour on its toll-free number. For any given hour, find the probability that it will receive at most 3 calls. So to get at most 3 calls, at most 3 means probability that x is less than or equal to 3. It means maximum should be 3. That's the meaning of at most. So it should be less than or equal to 3. And probability that x is less than or equal to 3 will be equal to probability that x is exactly 0, or probability that x is exactly 1, or probability that x is exactly 2, or probability that x is exactly 3. So, to find probability of x is exactly 0 using Poisson formula, what is the mean? The mean is 3, isn't it? So we say mean exponent x, our x is 0 at this moment, times e exponent negative mean over x factorial, plus 3 exponent 1 times e exponent negative 3 over 1 factorial, plus 3 exponent 2 e exponent negative 3 over 2 factorial plus 3 exponent 3 e exponent negative 3 over 3 factorial. So, when you put 3 exponent 0, e exponent negative 3 over 0 factorial on your calculator, you get 0.0498 plus, when you put this on calculator also, you get 0.1494 plus, this will give you 0.2240 plus, this will also give you 0.2240. So when you add everything together, you get 0.6472. So the correct answer for question 25 is D. Let's look at question 26. Question 26 says at least 3 calls. At least 3 calls means probability that x is greater than or equal to 3, which will give us probability that x is exactly 3. It said greater than or equal to 3, or probability that x is exactly 4 up to the last step, x is exactly n. But we don't know the maximum number n, so we can't use this method to solve it in Poisson. So we are going to use the complement method, which says that probability that x is greater than or equal to 3 should be equal to 1 minus probability that x is less than 3. So this will give us 1 minus into bracket probability that x is less than 3 means probability that x is exactly 0, or x is exactly 1, or x is exactly 2. Okay, less than 3, so we stop at 2. So this will give us 1 minus into bracket probability that x is exactly 0 is 0.0498 from here. Exactly 1 is 0.1494 plus exactly 2 is 0.2240. So this will be 1 minus, when you add all the values in the bracket, you get 0.4232. So 1 minus 0.4232 should give you 0.5768. So the correct answer for question 26 is C. So let's go to the next question. 27 says, to qualify for a police academy, candidates must score in the top 10% on a general ability test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume the test scores are normally distributed. Now what this means is, when you sketch a curve, they said candidate must score in the top 10%. The tops will be at the side. So top 10%. So let's say this side is 10%. 0.100. 10% means 0.1000. Okay. This area. Now, when you take a look at the question, the test has a mean of 200. So we've been given a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. So this question wants us to find x. Let's say when we have z is equal to x minus mu divided by standard deviation. The question has given us mu and has given us standard deviation, but the question wants us to find x. Now the question also didn't give us z, but we can use this 10% to get a z. Okay, so to get a z, definitely this place will be a positive value, isn't it? So we can get this side by saying 1 minus 0.100. That will give us 0.9000. So we go to the z table to check 0.900 so that we can get the score here. Okay. So when we come to the table, we have 0.900, isn't it? So 900. This is 8997, which is very close to 900, and this is 9015, which is more than 900, so it means it's between them. So since it's between them, we take the z-score of the two of them and find the average. So what is the z-score of this, it will be 1.28. You check at the top here, 1.28, and this will also be 1.29. Okay, so 1.28 plus 1.29 divided by 2 will give you 1.285. Okay, 1.285. So we've gotten the z-score to be 1.285. That's the z-score. So if that is the case, we can now substitute. So let's substitute 1.285 in place of z. Now let's substitute 1.285 in place of z. So we have 1.285 equals x minus, the mean is what? 200 divided by standard deviation 20. If we multiply both sides by 20, 20 times this will give us 25.7 is equal to x minus 200. So if you make x the subject, x will be equal to 25.7 plus 200. So that will be 225.7. And you can approximate it to 226. So the answer is D. Actually, just as we state the formula for z to be z is equal to x minus mu divided by standard deviation, we also have a formula for x, that x is equal to mu plus z times standard deviation. That's the formula for x. But if you remember this, you just use this straightforward and get your answer. But if you can't remember, just write this and you derive this from it. Okay. Or you use this like how I've done it. Okay. Because here, when you try to make x the subject, you get this. So let's proceed to the next question. Question 28 says, the average age of a vehicle registered in a country is 96 months. Assume that the standard deviation is 16 months. If a random sample of 36 vehicles is selected, find the probability that the mean of their age is between 90 and 100. The mean. They took a sample and the mean of that sample is between 90 and 100. So in this, your z won't be x minus mu divided by standard deviation. It will be x bar, because these two values are means. They are not just raw scores. They are sample means. And this is population mean. So sample mean minus population mean divided by standard deviation over root n. That's the formula you use here. So to find z1, it will be 90 minus the population mean, which is 96, divided by standard deviation, which is 16 over root a sample of 36, so root 36. So 90 minus 96 divided by 16 over root 36 will give you negative 2.25. Also, if we find a second z, that will be 100 minus 96 divided by 16 over root 36. And this will also give us positive 1.5. So if we sketch the curve, 0 will be at the middle, and let's say 1.5 will be somewhere here, 1.5. The negative 2.25 should be somewhere here. So we want to find the area between them. So to get the area between, we find area to the left of negative 2.25, isn't it? So negative 2.25, negative 2.25. This is 5 here. So the answer will be 0.0122. So 0.0122. So area to the left of this is 0.0122. Then we also find area to the left of 1.5. So we have 1.5 here, 1.50. The answer is 0.9332. Okay, so 0.9332. So to get the area between them, you say area to the left of 1.5, which is 9332, minus area to the left of negative 2.25, which is 0.0122. So let's subtract. So 0.9332 minus 0.0122 will give us 0.9210. So the correct answer for question 28 is C. So let's proceed to the next question. Question 29 says, in using Poisson approximation to the binomial distribution, which of the following is correct? So the answer is A. N times P will give you lambda. That is the mean. So let's move to the next question. Question 30. An average of 5 calls for services per hour are received by a repair department. 5 calls per hour. Find the probability that exactly 3 calls will be received in a selected hour. So, they said exactly 3. So, probability that x is exactly 3 should be equal to mean exponent x. And our mean is 5, isn't it? So, 5 exponent x, which is 3, times e exponent negative mean, negative 5, over x factorial. So if you put this on your calculator, you get 0.1404. So the correct answer for question 30 is C. So let's proceed to the next question. Question 31 says, the area under the standard normal curve between z is equal to negative 1.68 and z equals 0 is. To get this, they say z equals 0. We know that the middle is what? 0. And z equals negative 1.68. So let's say 1.68 is here. Negative. And this is the middle 0. They want us to find the area between them. So to get the area between, we know area to the left of 0 is 0.5. And area to the left of negative 1.68 will be, so let's check it, negative 1.6, then 8. This is 8, 8. So 1.68 will be 0.0465. So 0.0465. So to get the area between them, we say 0.5 minus 0.0465. And this will give you 0.4535. So the correct answer for this is A. So let's proceed to the next question. Question 32 says, which of the following does not apply to the normal distribution? A. The normal curve is unimodal. This is true. It has only one mode. B. The total probability under the curve is 1. This is also true. The normal curve is symmetrical about its standard deviation. I don't think this is true. The mean, the median, and the mode are all equal. This is also true. So C is the answer. C does not apply. The question says does not apply. Okay, so the answer is C. So let's proceed to the next question. Question 33 says, find the z-score corresponding to the 90th percentile. So what they mean by this is, this place means 90th percentile. So 90 over 100 gives you 0.9000. So we go and check for 0.900 on the z table to get a z-score, not a z-score to get it. We have the area already, so we want to find a z-score. So we look at the middle. Okay, so 9000. We have 9015 here and 8997 here. Okay, so it will be between them, isn't it? So the z-score of this person is 1.28 and that of this is 1.29. So 1.28 plus 1.29 divided by 2 give you 1.285. So the z-score is 1.285. So the correct answer for this is A, 1.28. Now, the reason the answer here is 1.28 is that when we go to the z table, the two values closer to 0.900 were this and this, isn't it? Now, this is more closer. This is more closer to 0.900 than this. That is why when you take the z-score of this, which is 1.28, so that is why the possible answer decide to use the z-score of this person, which is 1.28. Okay, so let's proceed to the next question. Find small z such that z is between this z and 2.5 is equal to 0.7672. Now to solve this, let's sketch a small curve. Now if 0 is here and let's say this place is 2.5, we don't know the second z, so let's put it somewhere here. The question is saying that this 0.7672 is the area between the second z and 2.5. So 0.7672. So if that is the case, let's find the area to the left of 2.5. Okay. So positive 2.5. That will be 0.9938. So the area to the left of this is 0.9938. Now if the area to the left of this is this, it means we can easily find this area by subtracting this area. So when we take 0.9938 minus 0.7672, we will get 0.2266. So if we are able to get this 0.2266, we can easily know what this z-score will be by checking the table. So let's go and look for 0.2266. So 0.2266. 2266. This is 0.2266. What does it correspond? It corresponds to negative 0.75. It corresponds to negative 0.75. So this z will be negative 0.75. The correct answer for question 34 is C. So let's go to the next question. 35 says, a fair coin is tossed 5 times and the number of heads recorded. Find the standard deviation for the number of heads that would be recorded. So to get a standard deviation, the number of coins is 5 and probability of getting a head in one tossing will be 1/2. To find standard deviation, now we know that mean is equal to n times p, variance is equal to n times p times q. So if variance is n times p times q, meaning we can easily get our variance. So let's find variance. N is 5, p is 1/2 times q is 1 minus p, which is also 1/2. So 5 times 1/2 times 1/2 will give you 5/4, which is 1.25. But the question asks us to find standard deviation. So to get a standard deviation, it should be the square root of the variance. So square root of 1.25 will give us 1.118, which is 1.12. So the correct answer for question 35 is A. Question 36. The average number of pounds of meat that a person consumes per year is 218.4 pounds. So this is the mean, average, mean. Assume that the standard deviation is 25 pounds and the distribution is approximately normal. If a random sample of 40 individuals, sample of what? 40 individuals is selected, find the probability that the mean of the sample will be less than 244. The mean, meaning sample mean. So for this, the z will be sample mean minus population mean. This is not a raw score x, it's a sample mean. So in this case, it will be standard deviation over root n. So the sample mean is 224 and then the population mean is 218.4 divided by, now our standard deviation is 25 over the n is 40, so root 40. So if you put this on calculator, we get positive 1.42. So let's sketch a curve. 0 is at the middle, isn't it? So let's say positive 1.42 is somewhere here. The question says less than So it means you should find this area. So to get this area, we go and check positive 1.42. So 1.42, 0, 1, 2. As you can see, 2. So that is 0.9222. So this area is 0.9222. And that's the area we are looking for. So the correct answer for question 36 is D. So let's proceed to the next question. Use the standard normal curve given to answer 37 and 38. Find the area to the left of Z. Now this is Z. This is 0. And this place is shaded. The question says we should find the area to the left of Z. It means we should find this area. That's the meaning. So if half of the curve is 0.5, and then we know from here to here to be 0.4175, it means that 0.5 minus 0.4175 will give us this part, because from here going is 0.5. And also from here to here is 0.4175. So to get this part, we can just say 0.5 minus 0.4175. So if we subtract, we'll get 0.0825. So the correct answer for question 37 is A. 38 is find the value of Z. They want us to find what will be here. So to get the value of Z, we can go and check this on the Z table. It will definitely be a negative answer because it's below 0. So we go and check it on the negative Z table. So we look for 0.0825. So let's look for that. 0.0825. 0.825. So we have 0.823 here. We have 0.9 here. So this is 0.823. This is 0.838. It means it's between this and this. But I think this is more closer. 0.0823 is more closer to 0.0825. So we take the z-score of this person. That is negative 1.39. Or you can take the z-score of the two of them and find the average. But I prefer to take negative 1.39. So let's check if it's in the possible answer. Yes, it's there. So the answer is D, negative 1.39. So let's proceed to the next question. Question 39 says, which of the following is true? The t-distribution should be used when A. The sampling population is non-normal. B. The sampling population is unimodal. C. The population standard deviation is unknown. The sample size is small and the sampling distribution is normal. And D. The population standard deviation is known. The answer is C. So let's proceed to the next one. Question 40 says, a tire manufacturer claims that each tire will last an average of 40,000 miles with a standard deviation of 3,000 miles. 49 tires were placed on test and the average failure miles was recorded. The probability that the average failure miles was more than 39,500 is, they say, average. So this is also mean, sample mean. A sample of 49 was taken and the sample mean is 39,500. So the Z formula you use here is x bar minus mu divided by standard deviation over root n. So our x bar is 39,500 and the mu is 40,000 divided by the standard deviation is 3,000 and the n is 49, so 49. So when you put this on your calculator, you get negative 1.17. So let's sketch a curve for it. So the middle is 0. So negative 1.17 will definitely be somewhere here, 1.17. But the question says more than. So meaning we want to find this area. Area more than. This area less than. This area more than. So to get this area, we need to know this area. So let's go to the Z table. Negative 1.17. So negative 1.1. This negative 1.1. Then 7 will be here. So the answer is 0.1210. 0.1210, which means area to the left. So 0.1210. So to get this area, we say 1 minus 0.1210. So that will give us 0.8790. So the correct answer for this is B, 8790. You can also check this negative 1.17 on a positive z table. So 1.17, 1.17. We get the 0.8790 straight. You see that? 8790. So let's proceed to the next question. Question 41 says, a statistics instructor with at least 20 years experience teaching the same course has established that 10% of all the students who take his course receive a failing grade. If 10 students have enrolled for his course next semester, the mean number of students who will fail is. Now, according to him, 10% usually fail. So, probability of failure is 10%, which is 0.1. Now, 10 students have enrolled, so n is equal to 10. So, to find the mean number of people who will fail, it should be n times p, which is 10 times 0.1. So, on average, one person will fail. 10 times 0.1 is 1. So, the answer is A. So, let's proceed to the next question. 42 says, if x is a normal random variable with a mean of 15 and a variance of 9, then probability that x is less than 18 is. We find the z-score. The z-score will be x, which is 18, minus the mean, which is 15, divided by standard deviation. But when you take a look at this question, they didn't give us standard deviation. We were given variance of 9. So we convert this variance to standard deviation by saying square root of 9. You know, square root of a variance gives us standard deviation. So if you just write a 9, you get a wrong answer. So it should be square root of 9. So 18 minus 15 is 3. And square root of 9 is also 3. So 3 over 3 is 1. So when we sketch the curve, 0 will be here, and then let's say 1 will be somewhere here. The question says less than, so meaning we should find this area. So to get this area, we can just check positive 1.0 on the z table. So that's 0.8413. So this area is 0.8413. And that's the answer. That's what we need. So the answer is B. Question 43 says, consider a Poisson distribution for the tossing of a biased coin. The mean of this distribution is mu. The standard deviation for this distribution is given by. Now, according to the question, the mean is equal to mu. Now, in a Poisson distribution, mean is equal to variance. So, if mean is mu, then variance too will also be mu. So, to get a standard deviation, the standard deviation should be the square root of mu. So, the answer is A. So, let's proceed to the next question. Question 44 says, in a large city, 50% of the people choose a movie, 30% choose dinner and a play, and 20% choose shopping as a leisure activity. If a sample of 5 people is randomly selected, find the probability that 3 are planning to go to movie, 1 to a play, and 1 to shopping mall. This is a multinomial distribution question. Now, the multinomial formula says that probability of x1 up to the last x should be equal to n factorial divided by x1 factorial times x2 factorial times x3 factorial up to the last x factorial times probability of 1 exponent x1 times probability of 2 exponent x2 up to the last probability exponent, the last x. Now, to understand this better, now when we look at this question properly, the probability of going to a movie is equal to 0.5, which is 50%. The probability of going to dinner is 0.3, that is 30%. And shopping, probability of shopping is 0.2. Now, but the question says if a sample of 5 people is randomly selected, meaning the n is 5, find a probability that 3 are planning to go to a movie, 1 to a play, and 1 to shopping mall. So we want to find a probability that 3 are going to movie, 1 to a play, and 1 to shopping. So that will be equal to 5 factorial divided by the first x, which is 3 factorial, times the second x, which is 1 factorial, times the third x, which is also 1 factorial, times probability of the first one is 0.5. So 0.5 exponent the first x, which is 3, times the second probability, which is 0.3, exponent its x, which is 1, times 0.2 exponent 1. So that will give us 5 factorial over 3 factorial times 1 factorial times 1 factorial will give us 20. And this will give you 1 over 8 times 0.1 exponent 3 is 3 over 10 times 0.2 exponent 1 is 2 over 10. So if you multiply all this, you get 120 over 800, which is 3 over 20, which is 0.15. So the answer is 0.15. So there's nothing like 0.15 in a possible answer. So you can convert it to percentage. 0.15 times 100% gives you 15%. So the answer is D. So let's proceed to the next one. Question 45 says, the first moment about origin of binomial distribution is. The answer is A. Whenever you see a question that asks you for the first moment, they are talking about the mean. Okay. Question 46 says, if calls arrive at a telephone exchange such that the time of arrival of any call is independent of the time of arrival of earlier or future calls, the probability distribution function of the total number of calls in a fixed time interval will be Poisson, B. 47. Consider a random variable to which a Poisson distribution is best fitted. It happens that probability of x is exactly 1 is equal to 2/3 of probability of x is exactly 2 on this distribution plot. The variance of this distribution will be. Now to solve this question, we know that Poisson formula says mu exponent x times e exponent negative mu over x factorial. So if that is the case, we have this probability of x is exactly 1 equals 2 over 3 times probability of x is exactly 2. Now what will be the probability of x is exactly 1? That will be what? Mu exponent 1 times e exponent negative mu over 1 factorial equals 2 over 3 times mu exponent 2 e exponent negative mu over 2 factorial. So this will give us mu e exponent negative mu, because this is 1, is equal to, now 2 factorial will give us 2. So this 2 can cancel this to 1. So we have mu exponent 2 e exponent negative mu all over 3. So if you multiply both sides by 3, we have 3 mu e exponent negative mu is equal to mu exponent 2 e exponent negative mu. So you can divide both sides by e exponent negative mu. This will cancel this. This will also cancel this. So you have 3 mu equals mu squared. If you divide both sides by mu, you have 3 equals mu squared divided by mu will give you mu. So mu is equal to what? 3. So the mean is 3. But in a Poisson distribution, mean is equal to variance. So since mean is equal to variance, then the variance will also be 3. So the answer is A. Question 48. Suppose that a book of 600 pages contains 40 printing mistakes. Assume that these errors are randomly distributed throughout the book and X, the number of errors per page, has a Poisson distribution. What is the probability that 10 pages selected at random will be free of errors? So to solve this, probability that one page will contain an error should be equal to number of errors, which is 40, divided by the number of pages. And also, the question says, what is the probability that 10 pages selected at random will be free of errors? So n is 10. So since n is 10, we can find the mean. Mean will be n, which is 10, times p, which is 40 over 600. And that will give us 2 over 3. So if it is 2 over 3, the question is saying that 10 pages selected at random will be free of error. Free of error means that there will be no error. So probability that x is exactly 0 will be equal to mean, which is 2 over 3 exponent x, which is 0, times e exponent negative mean, all divided by x factorial, which is 0 factorial. So any number exponent 0 will give us 1, times e exponent negative 2 over 3 divided by 0 factorial is 1. So the answer will be e exponent negative 2 over 3, which is C. Question 49. 10% of screws produced in a certain factory turn out to be defective. Find the probability that in a sample of 10 screws chosen at random, exactly 2 will be defective. Now, the probability that 1 is defective is what? 10%, which is 0.1. And how many screws? 10 screws. But the question wants us to find the probability that exactly 2 will be defective. Now, for this question, we are going to use Poisson to solve it. But before then, I want to use binomial, then we check something. Now, probability that x will be exactly 2 will be n combination 2, that's n combination x, times 0.1 exponent 2 times 0.9 exponent 10 minus 2. If you put this on your calculator, you get 0.1937. So let's leave that for now. Now let's use Poisson for it. Now to use Poisson, we need the mean. And the mean will be 10 times 0.1. So 10 times 0.1 is 1. So using the Poisson, probability that x is exactly 2 will be mean, which is 1, exponent x, which is 2, times e exponent negative 1 over 2 factorial. So when you put this on calculator, you get 0.1839. If you approximate this to 1 decimal place, you get 0.2. If you approximate this to also 1 decimal place, you get 0.2. You see that we end up getting same answer. But I'll advise you that you should use Poisson because whenever probability of success is very small, it is good to use the Poisson, okay? When the probability of success is small, you use Poisson, okay? So let's take the last question. Question 50. In a binomial distribution, the mean is 15 and variance is 10. Then parameter n, that's number of trials, is. Now to solve this, we know that the mean is n times p. And the question has given us the mean to be 15, so n times p is equal to 15. And it says the variance is 10. And we know in binomial distribution, variance is equal to n times p times q, which is 10. So if that is the case, if n times p is 15, we can substitute 15 here. So we have 15 q is equal to 10. So if we divide both sides by 15, q will be equal to 2 over 3. So if q is equal to 2 over 3, then p will be equal to 1 minus 2 over 3, which is 1 over 3. So we've gotten the value of p to be 1 over 3, but we want the value of n rather. So to get the value of n, we also know that n times p is equal to 15, isn't it? And we've gotten p to be 1 over 3. So we just substitute. N into bracket 1 over 3 is equal to 15. So if you multiply both sides by 3, we have n is equal to 45. So the answer for question 50 is C. So I'll end here for now. Please do also subscribe to the channel so that whenever I post more important videos like this, you can always have access to them easily. Thank you.